We'll try and understand the graphs in continuity. Okay. So what is a continuous graph that we'll try and understand? So we are having x-axis and y-axis. Okay. X-axis are having some values over here. Okay. Y-axis. Okay. Now when x is equal to 1, let's say y is also equal to 1. When x is equal to 2, y is equal to, let's say, 0. When x is equal to 3, y is equal to 4. When x is equal to 4, y is equal to, okay, there is no value for x is equal to 4. Okay, when x is equal to 5, the value of y is equal to, let's say, uh, 2, for example. So the function graph will be like this. Okay, so from here it can go like this also, right? Now, if you remember, couple of minutes back or rather seconds back, the value of y when x is equal to 4, I said there is no value for y. Okay, so what happens is there is a break in the graph. There is a break in the graph, as in this will be like this, and then when x is equal to 4, there won't be any value over here. Okay, and then this. Okay, so the graph will be something like this. So when x is equal to 4, y will not have any other value, any value rather. So this is a discontinuous graph because there is a gap. Okay, the curve was smooth. The curve was smooth. Suddenly, when x is equal to 4, there is no specific value of y. Okay, so there is a gap at 4. So that's the reason why the function is discontinuous at x is equal to 4. When x is very near to 4, it will have a certain value. Okay, from the left hand side, from the right hand side, when x is 3.999, it will have a certain value. When x is 4.0001, something like that, it will have a certain value of y. But then when x is exactly equal to 4, there won't be any value. Okay, so this is a gap. And whenever the graph has a gap, it is discontinuous at that particular point. So this particular curve, okay, this is f of x curve. F of x is nothing but y. So y or f of x is continuous at all points between 1 to 5, because we took the example from points 1 to 5. For every value of x between 1 to 5, we are having a specific value of y. Okay. See, for 2.5 also we have a value of y. For 4.9 also we have a value of y. Okay. But then only for 4, there is no value of y. So this is a discontinuous, uh, this is a case of discontinuity only at one point, which is x is equal to 4. Okay. For other values, for 1, 2, 3, 4, 5, okay, and also all the decimal values, there is a specific value of y. So it is continuous at all the other values between 1 to 5, except at x is equal to 4. So if someone is asking you if it is continuous at value 3.7, okay, so 3.7 is somewhere over here. Yes, it has a certain value. It is continuous at 3.7. So there is a specific value of y. Okay, but then only at x is equal to 4 it is discontinuous because there is a gap. That means there is no value of y. Now there is also something which is called as jumps. Okay, so let's take an example. Okay, so this is 1, then 2, 3, 4, 5, so on and so forth. This is the x-axis. This is y-axis. Y is nothing but f of x. So the curve starts from here, and as soon as x takes up the value 3, x takes up the value 3, okay, there is no value assigned over there. And suddenly the graph will take a new position. So the new position is over here and it will continue from here. So this is not a gap, but then it is a jump. Okay. So the graph, okay, jumps from this particular point to this particular point and takes up the new shape, takes a new shape. Okay. So whenever such kind of jumps are there in the graph, so this values are also this type of case is also discontinuous at that particular point. So there is a jump at 3. Okay, when x is equal to 3, there is a jump. So it is discontinuous at x is equal to 3, but then for other values it is continuous because there is no gap or jump for any other values of x. Okay, for 1.5 it is over here, for 2.1 it is over here. So there is no gap or a jump. Okay, so you should know this gaps and jumps from graph perspective. Okay, thank you.